Yeah, we are live. 6:53, 7 minutes to spare. So all of you people that are not on time, where are you at? Come on, what's going on? Tonight we're talking about lots of cool stuff. Hope you guys all had a very Merry Christmas. Hope it was awesome. We did. It was great. It was fantastic to get to see all the family. You know, whenever you get together with family, there is always chaos. It's awesome. That's why I look forward to the holidays. Something exciting is always going to happen, and it did, and it was awesome. The biggest thing is my son. He recently got his license and he got a car, so he got his very first car. So it's a big deal. That's an exciting time, and you're young, and you know, it's a time you should remember. It's awesome stuff. So lots of cool stuff. Hopefully you guys are doing well. Hopefully you guys have made plans. Everybody should make plans like I did, or at least promises to get all of your projects done. I have the GLH sitting in the backyard. I have the Nova sitting in the backyard. So 2022, those are both going to be running. So that's my goal for that. Got lots of testing coming up. My next trip to Wastegate should be chock full of 3800 goodness, including turbo stuff, hopefully Magnum stuff as well. And I'm looking forward to getting the 4200 back together and making some pretty big numbers. Calvin's been throwing out some big stuff. So if you guys haven't seen his stuff, go over to Nivlac, NIVLAC 57 on YouTube and check out Calvin. He does lots and lots of good stuff. He's got actually lots of cool parts available for the 4200 Atlas, and I'm assuming that some of that carries over to the 3700, which I think is the 5-cylinder version, and then also the 4-cylinder version as well. So I'm looking forward to us doing stuff together and then seeing some big numbers on one of these motors, because I have 2 of them, and so I might as well try to break at least one of them. So we got some cool stuff coming up from that. I can't wait to try the different boost levels and the different the adjusting the variable cam timing, addition to air fuel and timing and that kind of stuff. So it'll be cool to see finally to put some, head studs on there and kind of really get after making more boost. I think we've made 550 or something like that, somewhere in that neighborhood the last time we ran it, and that was not a good specimen. Now with the head being redone and stuff, when we put it back together, it should be able to make some good power. The guys at Schneider Racing, shout out to those guys over there who do awesome work. They're doing a set of cams for me, so we'll be able to put those in. That will be good. And then I will, by somebody, get some cams done on the 4200 as well. So we'll be able to get, ported head cams and make lots more NA power. And as we've seen time and time again, every time you make more NA power, you make more boosted power. That's the answer there. The video that I put up today was on the electronic boost controller, which is very, very cool. And I remember seeing this for the first time way back, and somebody trying to explain it to me. And I'm like, it's not going to make any difference. That's just dumb. It's just the wastegate. It's just controlling the wastegate. You can't have any more control over the wastegate. That's just silly. That doesn't make any sense. And then you look at it, you're like, oh yeah, I could see where that would be a problem with it. So what's happening, for guys that don't understand, is when you have the way that a wastegate works is it has a boost reference line, it has a spring, and then the boost works against the spring, basically to open the wastegate up at some pressure, whatever the spring rate is. So if you put a 7-pound spring in it, and as soon as the thing reaches 7 pounds, it opens the wastegate up, and then that stops some of the exhaust energy going to the turbo until it stabilizes back at 7 pounds. So gives you enough exhaust energy so that the turbo will only make 7 pounds. The problem with that is the way that a wastegate works is it's just a valve basically that opens up that allows exhaust gas to exit out of the system. And the problem with it is it's not exactly precise. So the spring doesn't say, okay, I'm not moving until I see if it's rated at 7 pounds. I'm not moving at all until I see 7 pounds. It moves a little bit at a 5, a little bit more at 6, and then a lot more at 7, and then bleeds it out. And the problem is that when you're going into boost, it'll start bleeding exhaust energy at 5, 6, 7 pounds, whatever the numbers are compared to what it was, or compared to what you have the spring rate set at. And the nice thing about an electronic controller is it doesn't just have a reference line going to the bottom, which basically pushes up against the diaphragm. It also has one at the top. So what it's doing is using some of that boost to basically hold the wastegate closed. So it holds it closed. It says, look, you're not opening it. What I want out of this deal is I have it programmed for 7 pounds. So you're not opening until 7 pounds is reached. So you're not opening at 5, you're not opening at 6, you're not opening at 6.5, you're not opening till 7. So the boost ramps up with a turbo, and the way that it ramps up is not affected by the controller basically, but it ramps up to whatever that opening rate is, let's say 7 pounds. And then what it does is that the wastegate, if it's working well, it just maintains 7 pounds all the way out through the rest of the curve. Works very well. And as we saw in this video, the cool thing is that in the lower part of the curve, while the thing is ramping up, that's where you get a lot of gain. You can get a gain depending on how ineffective just the spring or any kind of manual controller you might have on there, how ineffective that is in whatever curve it's supplying. Because the problem with using a spring or using a manual controller is that you're not dictating a specific boost number. So if you turn the thing up, okay, I've turned the valve 1 turn, whatever that is. The other thing that happens is on a turbo system, because the valve is experiencing also back pressure. So back pressure is pushing against the wastegate valve also, and wanting to open it up, same as the boost is doing. So you have both of those working together. So the problem is, even if you have a 7-pound spring, you have the boost trying to open it up and the back pressure. And so a lot of times you don't get what you want. You don't get what the spring is dictating. You get whatever that combination of those things is. And that's the nice thing about having a controller, is the controller to some extent can overcome both of those until it can't. I mean, at some point you need to have, like, you can't put a 7-pound spring in there and then put an electronic controller on there and hope to run 30 or 40 pounds of boost. It's just not going to do that. It doesn't have that sort of dynamic range. What you need to have is, if you want to run 40 pounds of boost, you need to have a 20 or 30 pound spring in it. And then the wastegate controller can control it the rest of the way and not allow it to open. And the other thing is, the more back pressure you have pushing against trying to open that valve up, the more spring pressure you have that you need to have to try to counteract that. So all that stuff is really cool. And I plan on doing a much bigger wastegate and controller kind of video. And I want to be able to film it and show people and do an inside view of the wastegate and where it is and what it does and all that. So that will be good, so people can have a better understanding, because it's important to understand what's going on, to know how you could make something better, or maybe that there's not a need to make it better. Maybe it works well enough for what you're doing. But before you can decide whether or not that's the case, you have to understand how all that works. And a lot of guys don't. I mean, I remember back when I didn't have any idea how turbos worked or how wastegates worked, or, we all learn as we go. So there's lots of people out there that don't understand it. So I'm going to do a video for them so that they do understand it and get a good feel for it. Then can go, oh yeah, here's probably why I need a good wastegate. Because if it doesn't open up, then bad things are going to happen. Or if it opens up early all the time, I'm never going to be able to get the boost that I want. That actually is the more desirable of the two outcomes. If it doesn't ever open up at all, and you're not real spot on your tune and taking timing away and doing all the safety features, then there's a very good chance that it's going to blow up. So you don't want to do that. And that's another important point about hooking up any sort of controller properly. If you don't hook it up properly, you can have all of the boost going to the top, and then you have the spring pressure plus the boost pressure trying to hold the valve closed, and it will essentially hold it closed all the time. So then in that case, it'll just make whatever boost the turbo will make. It's just unlimited. Oh, okay, yeah, you want to get in let's party mode, so let's party. And that's exactly what it does. Unfortunately, it usually breaks things down low, because it's able to run, I don't know, 40, 50, 60 pounds of boost, whatever that turbo will support down low. Up at the top, it's not going to be able to do that, because then it's really having to flow some air and stuff. But like at 3,000 or 3,500 RPM, if the turbo is up and working and you don't regulate it and it can make whatever kind of boost it can make, that's usually asking for trouble. So the electronic control thing was really cool. And what we see is that instead of having a curve that's dictated by the combination of spring rate working against the boost pressure and the back pressure, when you dictate, like with our TC1, and there are a lot of other good ones from Turbo Smart in various places, you can decide how much boost you want to run. So if you program in, okay, I want to run 10 pounds, then what happens is However, the boost comes up as soon as it hits 10 pounds. Then the waste goes. Then the controller says, "Okay, we're in control now. We're only going to allow it to make 10 pounds." And but we don't want it to make less than that. So it just hovers right around the 10-pound range, and it's nice and flat all the way out. And I showed that in the video. We ran it at like 8.2 or 8.3 pounds, and then 9.5 or 10, and then 11 and something. And again, it was the same thing. They just come up and then they just carry nice and flat, nice and flat, nice and flat all the way across. And it was a good comparison to the other ones that didn't work that well. So we have somebody that needs to get booted off of here. I don't know why people are knuckleheads. So that's how they work. The electronic controller is very cool in that way, and it allows a nice curve. One of the things that where people get controlled about controllers is that or they get confused is that they think that it's going to help their turbo spool up. And we saw that it does indeed help in the area where the manual controller or no controller at all is already starting to lift the gate. There will be improvements there. But there won't be any improvements down in the area where the turbo is still getting up to steam to make the boost at whatever you have it set at. So if you have the thing set for 10 pounds, until the turbo spools up to 10 pounds, the wastegate controller isn't doing anything. And having no wastegate controller isn't doing anything unless it's bleeding boost a little bit. Then as we saw in that area, the wastegate controller can help. But if you don't have full boost until 4,000 RPM, at 3,000 RPM, the electronic controller isn't doing anything. It's not improving your life. It's not making it spool up any faster. All of that spool up is a function of other things. It's a function of the two big things are the power production, the torque production of whatever that motor is making at 3,000 RPM, combined with whatever size turbo you're using and the amount of exhaust flow that amount of torque is producing, and then the amount of boost that it can produce in that combination of stuff. There are other things that will affect that. So maybe the size of the Y pipe, maybe the exhaust that you're using, maybe cam timing. But again, all of those things would affect the NA power output. So the NA power output for me is always the big thing. How much torque are you making there? And if you use the bigger motor, it would have more exhaust energy. It would spool a turbo quicker. If you use a smaller turbo, that amount of exhaust energy would spool a turbo up quicker. And so that's the way that I look at that. But again, remember that the wastegate controller isn't controlling the way the turbo spools up from 0 pounds of boost to whatever you have it set up at, except right at the very end compared to not having one. I really like electronic controllers, and they're very cool. I especially like, and I haven't got to use it yet, and that's on my list of things to do for 2022, is I haven't used it and scaled it in relation to RPM. So I haven't drawn the boost curve that I want it to produce. Having it do a flat one is what it's designed to do. So you just put it on and say, I want 10 pounds. And then it goes, okay, when you get up to 10 pounds, we'll let you know, and we'll just clip it at 10 pounds, and then it'll go 10 pounds flat all the way across. And so that's easy. But what we want, and what we want more for the big bang stuff, is that we want a rising boost curve. We want the problematic boost curve that we're trying to alleviate with an electronic boost controller, but only in that specific example, because we're trying to minimize torque production. And that's one thing that a flat boost curve does. If the thing ramps up as quick as it can to whatever boost level you have it set at, then it's going to make a lot of torque. And that's what we saw in this video, is that we saw a big change through most of the curve, especially in what we call the torque plateau area of that 4200 Atlas motor. It had a nice flat area where it was making about 500 foot-pounds for a fairly long spread. I'm thinking it was about 1,000 RPM or something. So on our big bang motors, where that's 1,200, 1,300, 1,500 foot-pounds, we don't want that to happen. So we want it to rise. And so I'm excited about doing that with whatever turbo motor. We're going to be running the 3800, obviously, with a turbo, and big blocks are coming up, and we have a lot of things coming up. So I want to just be able to scale that with RPM and make sure that it works, so that when we do employ it, and the first one we probably will employ it on is the big bang big block, the 454. So I'm hoping I can get the camshaft and spring situation straightened out with that motor so that it will rev out to 6,500 and at least make power out there and not just be flat like it's been in the past. If we can do that, then I can get the turbos. We have two S475s and we have the air-to-air or air-to-water intercooler, and we have it fuel injected and it's a blow-through deal. And then we can run it and not have to have like 1,500 horsepower and 1,500 foot-pounds, because that's usually what's going to break that. The other thing we can talk a little bit about tonight is, and then I'll get to your questions, is that the video or the photo that I have up, the thumbnail for this video, is that I have a photo of my buddy Jimmy Hiddle's NSX, and it's an NSX all by itself is cool. I know I used to have one, and they're fantastic cars, but his is even cooler because it has a J32 swap going in it, which is very cool. Now, a lot of you might think, oh, well, why would you take out the NSX motor and put in a J series Honda? Well, the reason that you do is twofold. One is the cost of an NSX motor is very high now, much more than a J series is. The J series, his is an early motor. His is an early NSX, so it came with a 3-liter. And his J series, his J32 is a 3.2 liter. You could also get a 3.5 or 3.7 and have even more torque, which the NSX was not famous for. It was, I know, because I used to love, first and second gear were a lot of fun in those because they would run out to, we'd run to 8,000 or 8,500, and it had enough gearing in it that it felt pretty spirited, and the thing would hook up fairly well because it was a mid-engine and it had a lot of weight over the traction wheels, so that it would hook up pretty good. But it's not tremendously powerful. It was really good once the guys, Jimmy and the guys and Nathan, put the turbo system on it. Then it was a lot of fun. Then it was the way that it should have come from the factory. So he's going to have a lot of fun having a much more torquey motor, and then he's going to do lots of cool stuff to it. The video, the photo that I have up is the turbo kit that he's making for it. So he's positioning the turbo, and he's done a lot of kits and developed a lot of kits and designed a lot of kits when he was doing this stuff for HP. Lots of the modular stuff and the 5-liter Fords and all that. So he did a lot of cool stuff. But the NSX should be a lot of fun. And I know, having driven a turbo NSX, and a 3.2 liter will be even better because it'll be torqueier. We're getting a set of cams from the guys at Schneider for that J series. And Jimmy's going to do a bunch of testing, and he's promised to send me a bunch of photo and videos and stuff. So I'll be doing some stuff on the J series NSX deal. And, I'm excited about going back to visit them when the thing's running and being able to take a ride in it, because it'll be cool. Because, like I said, a turbo NSX is an awesome thing. And having it be an even bigger motor. And like I said, we're going to go through cams and ported heads and that kind of stuff, and it'll be good. So let's see what you guys what you guys have going on. Hopefully everybody had a good Christmas and everybody was safe and are looking forward to the new year. Charles, hey Robert, I'm stuffing L33 aluminum 5.3 in a 2000 Isuzu Amigo. Nice. Are you going to do off-roading with it? Noodles, Charles, Kevin, Tim, everybody, happy birthday. Let's see. Go for broke. I have a J32A2 here for you to test. Where's that at? Because I am going to run a J series on the engine dyno. Who doesn't want to see a 12A rotary rev to $9,000? I just want to do a turbo rotary. So Rob, if you're listening, Richard wants to do a turbo rotary on the engine dyno. Brian, have you ever tested a built Toyota 22R? I have not. I've seen some in some little trucks and stuff that guys ran on the chassis dyno, but I've never even put one together. I got, Dan wanted to know what I got for Christmas. I actually got some more green screen stuff. So hopefully in 22, we should be seeing fancy green screen stuff. USV 568. I would like to see Mopar 57, 61, 64 Mopar builds. I know the problems with these motors are the ring lands. I believe max boost is 5 to 6 pounds. You need to take a look at the videos that I have up on the Hemi stuff. It's a lot more than 5 or 6 pounds. We've done way over 1,000 horsepower with a stock bottom end. The key is get ring gap in it, just like with all of these motors, but even more so with the Hemi because of the ring land situation. But they'll take a lot of boost. Von Steel Wind. What spark plug heat range would you recommend for the 12.15 to 1 NA408 LS engine I'm building? 54 469-11 cam or running 93 octane and live at sea level if that matters. I think you can get away with 93. I mean, if you find yourself having to put a little bit of octane booster in it, that would probably work. I don't think 12 to 1, that's just a little over 12 to 1. I don't think you're going to have a problem on 93. Dan, but seriously, don't most aftermarket ECMs have boost controllers built in them? How would they compare to a standalone controller? I don't think you'll see much difference in controller to controller. I don't think, unless one of them or more might have more resolution, because you have to fiddle with the duty cycle and stuff to get them in the range that you want and at the boost level that you want. The MS3 Pro that we were running the 4200 on had the ability to do that. We just didn't hook that up, and we already have the TC1 basically is already wired on the dyno, so it's a really simple hookup for us. That's why we use it. Between a Series 1 L67 and GM Atlas 3700. Well, the 3700 is the 5-cylinder. Which should I pick up to play around with? The 4200 makes a lot more power than an L67 does. I mean, the supercharged version makes about what the NA 4200 does. So if that gives you any idea, and both of them work well, I think it would be more packaging than anything else. A V6 might package better in some instances than an inline 6. Lee, I have a 1,600-pound 71 mg midget that needs a turbo rotary. Yes, it does. Football person, will you be throwing boost at the 5.9 Magnum in the future? Yes, it will get boost hopefully almost immediately after we get it running again. Sorry, I'm late here. I had to run to the store for some frosty beverages. I scored big today at the store. We've been going to the store to get a specific thing that we like to have, and they've been out of it. Maybe because we've been buying all of them. But I found some at another store today, so it was a big score. The MG would haul with a turbo, Dan says. Yeah, it would. Another popular one is the bug-eyed Sprite. So a Sprigget, I think that they call those. So a bug-eyed Sprite with a rotary in it was always very cool too. Where am I at here? Yeah, Charles, we all need reference slips, right? After you put it together. Robert, custom header question. Fabbing custom NA 32 valve mod motor headers, but a limited space for packaging. Would rather have a straight section right after the port or equal length runners. Honestly, I don't think you're going to see a big change from either one of those. Most of the headers that we run on the engine dyno are not equal length, and equal length shorties are a waste of time. And even the equal length stuff, ideally equal length long tube headers are a good idea, but sometimes you just can't package that. And I don't think it's judging from some of the changes that we've seen, in only primary length, if you don't change anything else, there's not a dramatic change in power there. Big No 210, what's your go-to LS boost controller? For us, it's the one that's hooked up already, only more as a matter of convenience. I think you can get what you need from a lot. There's a lot of them out there. For that 12-to-1 NA LS, would I need a colder plug? Yeah, I would definitely go colder than stock. I'd probably put a 7 in it or something. One bad AMX. Hi, Richard. How will ring gap react on an NA motor till it gets boosted? It's not going to change it at all. When we ran it on the 5.3 and the 6.0, it didn't seem to change power at all. Jeremy, what's the most boost you've run on the Atlas, and what was the horsepower? I don't think I've run more than about 11 or 12 pounds on it, and I think that it was less than 600, if I remember right. Yeah, it was a little over 500. No, it was a good bit over 500. I'm going to check here real quick. Yes, 550 at 11 pounds on the boost on the Atlas. Tim, is there any benefit to using adjustable cam sprockets on a stock single overhead cam engine? We've used them on Honda applications, and we use them on modular Fords as well too. What are your thoughts on a turbocharged 305 just for a little fun truck? Turbocharge whatever you have, anything that you have, a 2.8 liter V6. It doesn't matter what it is. People will tell you to get rid of the 305. You can't run a 305. You have to run a 350. You can run a 305, a 307, a 267, whatever you have. You can add boost to it, and boost will make it better. Charles, I will have a 3.2 Isuzu V6 for sale when the swap is complete. 6VD1, 205 horsepower, and aluminum. That's a good motor then, right? Lee, I don't really have any questions for you tonight. Come on, you got to think of something, man. But I just want to thank you for all the wonderful free knowledge that you share with us. I'm happy to help, man. I know Rob needs to spread that rotary love. I would love to have him, and I would even buy the motor or whatever if I could find a junkyard one or somebody had a used one. I would love to go over and have him show me how to, just show me the ins and outs. I'm sure I can figure out where everything goes, but it's always better to have a guy that's done a lot of it and just put one together that I could run and have somebody port it that knows what they're doing, because I have no idea. I've seen bridge ports and peripheral ports and stuff, but I've never done it. So I'm just like, I'm not a head porter. I'm not that kind of porter as well. But I'd like to try different intake lengths on them and stuff. And I think that it would be kind of cool. Would there be any issue with a piston valve clearance using a Summit 234, 248, 113 plus 3.5 cam and an LS53 and 5.7 using the stock heads? You're definitely gonna have to measure that. That's right in the range where I would definitely measure it. Zip ties on the wastegate line. We do that. Is there a good rule of thumb for spark plug heat range? We normally run a lot colder than other people do, and I hear this myth, and I don't know, maybe it's not a myth, but about people driving around. I've driven around in my Civic at less than 10-to-1 compression with the turbo motor that we ran at Bonneville, because I also just drove it around. And we ran with IQ 31s, which I think is the equivalent of a 10 heat range. And it drove around fine. It didn't misfire. Now, we only had about 19 thousandths ring gap in it, but it didn't have any misfire. The thing drove. It got fairly good fuel mileage. I mean, it did all the things that it was supposed to do. And we don't see that kind of misfiring, idling, and part throttle and that kind of stuff on the engine dyno. But other people might have more experience driving those colder plugs out there. But I've driven them around on various things, and I've not had problems with them. I'm impressed with how quickly Richard got the numbers. Well, as luck would have it, that is exactly the one that I was working on today. So that file was already open. And when I do these videos, I grab all the files that I'm working on and put them in one file, all the dyno runs in one file, so that when I have to go back to them when I'm doing the overlays and stuff, it's just very quick. I don't have to go search through it and stuff. And so it was an easy thing. But, you know, if it makes me look like a hero, it makes me look like a hero. I'm not going to argue with that. Mazda sells a crate 13B. Wow. Yes, everybody make sure to hit the like button. Like, share, subscribe, ring the bell, do all that stuff. And this is included in that. Patrick, is it worth it to do a CNC LS3 or TFS 205 heads on a 79 Trans Am with 140,000 miles while doing a rebuild with a truck Norris cam upgrade, or wait till after a turbo kit? If you're going to do a turbo motor, you don't need either one of those heads. If it's a 5.7 in a Trans Am, you can't put the LS3 head on there anyway. So a TFS 205 head would be a much better choice. Or you could put a ported 243 or a 799 or a trick flow 215 or probably even a 225. But if you're going to do a turbo motor and you're going to run 1,000 horsepower or less, you don't need a ported head anyway. Just put the stock head on it with a cam and away you go. Do you have any plans building a second-gen LT1 using the GM LT4 heads you flow bench earlier this year? I think I sold the LT4 heads. I have some more LT1 heads, and I am going to do some more LT1 stuff, but I don't know if I'll do it with the LT4 heads. I'll have to see if there's another set there. Jeremy, I'm currently working on an Atlas for boost. I'm looking at putting a VSR 80 millimeter with a T4 divided flange. Do you think 80-pound injectors on 91 pump will work? Yeah, 80-pound injectors will get you fairly far. Let's see, 80 times 2 times 6 times 0.75. Yeah, you could go to 700 or 720 or something like that on gas, not on E85. Be a lot less on E85. But in my opinion, that an 80 millimeter turbo on that Atlas you're not going to be that happy with unless you're trying to make. I mean, that's a 1,200 horsepower turbo, and you're not going to do that on 91, and you're not going to do that with 80-pound injectors. I would suggest a much smaller turbo than that. The GT45 would be a much better turbo for that, for what you're talking about. Eric, what do you think about a tri-Y header for an NA engine? I read somewhere back in the day that they are the best. There's no one single design element like that would be the best for every application, not for every NA engine. The Cup guys use tri-Y stuff. but what they're using is whatever makes the power curve that they needed for their motor, for their specific application. There's no general rule that tri-wise are better than 4-into-1s and any of that. If you're trying to optimize every last horsepower out of it, you then you, like what I was talking about with the NASCAR stuff, you even then have to get specific about where you want that power. On a super speedway, you don't care about power at 3,000 RPM. You really care about power up on the big end. And so, and on a road race car, you may want a broader torque curve. So you may want a different header configuration. I'm almost certain that they would do that. And so it depends on what you're trying to do. There's no absolute like that. What is the difference from a hot plug to a cold plug? Do you mean in the way that they look, or? A 7875 is not going to spool very fast on a 4200. A GT45 would be a much better choice on the 4200. It just doesn't make enough NA power. Randall, I'm anxiously waiting a Make It Better with Turbo Magnum dyno. It's going to do, and this is, it's kind of the unfortunate part about doing all this testing is when you have like the Magnum, for instance, in stock trim is a 300 horsepower, 400 foot-pounds kind of thing. And if we added a boost to that, we kind of know what's going to happen there, right? I mean, if we ran 14.5 pounds, we could get to 600 horsepower. That's not the way that I would do it with a stock cam. We might try that just so that I have stock cam numbers, because I always reference back to that stuff when I'm putting these videos together. And so that's always a good thing to have as a stock one, because as we know, a stock cam was not designed by Dodge in the Magnum as a turbo cam, and yet it works. Ed, is it okay to run gravity-fed fuel to a carburetor on a turbo application, or is a pump needed? Taking a look at boosted go-karts, is the carburetor in front of the turbo, or are you blowing through the carburetor? If you're blowing through the carburetor, you're going to have to pressurize the fuel. JB, I just started pulling out the 305 TPI T5 combo on my 92 Z28. Thanks to your shared knowledge, I have the formula to jump Coke bottles. Ooh, not even Coke cans, Coke bottles. Saucy. With my LS7 T56 Magnum. Nice. What's your recommendation for cam and headers for a turbocharged 305? You're limited in what kind of heads that you can run. So you can port the stock heads or leave them stock. I don't know how much power you want, but I would put a cam in it. I'd put a fairly mild one. You can take a look. I have videos up of 305s that we did with various 264 cams or 270 something cams. Those are duration numbers, advertised duration numbers. And so they're going to be 218, 224 kind of thing. And that works pretty well on a 305. You don't need a lot of camshaft because the turbo is going to dictate how much power you have. So if you have a mild cam, you're going to be able to spool the thing up really well. And then all of a sudden, the turbo is going to be much happier. Jeremy, I already have the 80 millimeter sitting on my bench. Well, that's a good reason to use it. I did all that stuff. See, that's what I like to hear. Tune port with a turbo will be a torque monster. I have videos up on that, and they are indeed very extremely torquey, just like they are NA. Dan, in Cup, we ran different headers for different tracks. Not surprising, had lots of header packages. I had a friend that worked at, not Childress. Who are the people out here in California? Cosworth, I think. I think he worked for Cosworth. But it was amazing how many different engine configurations and stuff that they had for different tracks and stuff. It was really pretty cool. Have you tested hooker comps or super comps? We have lots of super comp headers at Wastegate because they have a bunch of them from Hooker. Russell, I plan on running a compound boost system. What I want to know is if I use the boost controller to turn the turbo all the way down to 0, you want to run no boost from the turbo? You want to run it all the way down to 0? Maybe I don't understand. Jose, is a hotter plug better for a turbo or a colder plug? When you go to boost, you're going to want to run a colder plug than stock. KD, my little twin turbo 305 is TPI too, so it's got to be pretty torquey then. Richard is always correct. We know that that's not true. Everything about testing twin S475s on an LS408, that's like 2,000 horsepower worth of stuff. And so you could do that if the motor would take it. Did the Atlas have custom ground cams? The one that I did the video on today was just stock cams. I have custom ones being done, but I haven't run them yet. Steve, here in the Northeast, I went with a T304 Stainless Works header for my 383. I know those weren't cheap. 383 LT4, that's a fancy motor and car. Camaro, due to the salt that's always in the air near the Atlantic Ocean and salt on the roads. That's true. It will destroy them. Just need a really, really high fuel tank for gravity feed. For longevity, what are your thoughts on putting 6.2 pistons in a Gen 3 6-liter? I haven't ever seen one bored out that far. I'm told that you can, but again, I would want to sonic check it to make sure that you have enough wall thickness for that. Going from a 4-inch to a 4030 is pretty common on the iron blocks. Going all the way out to 465, that's a lot. You just need to check it. I don't think I would run boost with it for very long. If you're and on the 6-liter question, if you're running boost, I definitely wouldn't do it. The boost can do everything that you need it to do. You don't need more displacement. One, I have a Gen 3 6-liter block with Gen 4 internals, good flat top pistons. I do want a turbo, but don't know if a 4-door Silverado 4-wheel drive will be the right thing to do. I don't know about what you're putting it in and what you're planning on doing it. You can make a lot of power with the Gen 3 6-liter block and Gen 4 internals. Just look at the big bang stuff. You can make a gazillion horsepower. And everyone's telling you that, yes, it's the right thing to do. That if the question is turbo, the answer is always yes. Also, what cam can I put in for the motor to handle the turbo? Anything, really. I have a couple turbos left over. I mean, I have a couple cams left over. If you want one of those, they will work very well for your application. A Truck Norris cam, anything from a stage 1 up to a stage 3 or something will work. I like smaller cams in these applications just because they spool the turbo up more, and you can always make whatever the turbo will make, but that's just me. Jose, thanks for the content. Always good to bring up your name in a conversation. It probably depends on who you're talking to. Joe, could you do a video respecting head flow numbers and selecting the right cam and spring? Honestly, I don't subscribe to that. I don't subscribe to the head flow and cam choice selection. I've done too much testing with the same head and multiple cams, and guess what they all do? They all work like they're supposed to, and they all work the same on a different head that has wildly different airflow, and they work on that too. So I think that when somebody tells you that I took the head and I floated and it did this and I matched the cam to that, all they did was select a cam and combine it with that head. They didn't show you any other data to show you that if you put a different camshaft in there, it's just going to do what the different cam does. It's not going to be that one is ideally matched to the head flow. I don't agree with that. I don't believe that that's accurate. Richard, with turbos, you need to be sure to size them. To size, what are we talking about? I don't know what we're talking about sizing. Okay, here we go. Yeah, so you had more of a question. I didn't see what was going on there. Richard, with turbos, you need to be able to size them for your setup. Yeah, you should size them for the combination of your power output and then whatever your needs, because you always want to balance size and then response rate. So you have to do that. Do centrifugal blowers have that same mentality? I feel like compressor sizing wouldn't matter much because lag wouldn't be different. It is, because you can have, there's no reason to put a blower that will support 1500 or 2000 or 3000, whatever the number is, horsepower on a combination that you're trying to make 700 horsepower with. You could size the centrifugal blower to work in the power level that you're looking at. Usually you have excess, just like I have suggested always with the turbo stuff. So if you want to make 700 or 800 horsepower, get 1000 horsepower turbo, because you're eventually going to go up. And it's the same thing with the blower. And this works the same thing with positive displacement blowers too, is that that picking a bigger one can be a good idea if you plan on moving up. But if you don't, the smaller blower spun a little bit faster will be more responsive through a lot of the curve. And the same thing with the centrifugal. If you pick a supercharger that's designed to make 1500 horsepower, there would be a better choice for one when you're only trying to make 700. Charles, what's the difference between an L33 and a Gen 4 5.3 besides the aluminum? I don't know if all the Gen 4 5.3s were flat top pistons. The L33 was like an HO version. It had a different camshaft, and I don't know if it shares that camshaft with all the Gen 4 stuff. I don't think it does, because I think that some of the truck stuff is rated differently. Somebody told me that all the Gen 4 motors have 243 or 799 heads on them. I can't swear to that because I haven't seen a lot of them in the wrecking yards. All I see are Gen 3 things, but I don't know for certain about if they were all flat top pistons. I don't know if only the HO, like L33 or the LC9, the higher rated power output ones. But I remember testing the L33 camshaft too, and it was definitely different. I know there are tons of variables, so you've already answered your question, but is there a general rule of thumb for how much power you can make on a streetcar on 91 pump gas? I've seen guys make more than 1000 horsepower NA on 91, but they do it with a big motor. So it depends on how you want to go about it. How much do you think a 1999 5.3 LS with stock truck intake, sloppy stage 2, milled 25? I'm hoping 320 wheels. Do you think this is possible? I don't know about your tire size and drivetrain and all that stuff, and I don't know what it started at. I know that floppy stage 2 with a 5.3 that has headers on it and it's tuned properly and stuff, could certainly go over 400 flywheel and probably more like 420 or 430, I'm thinking. Does CO2 spool the turbo faster and is CO2 better than an electronic controller? So if you're talking about putting dome pressure on it to hold the wastegate closed, no, that won't spool the turbo faster because it has no effect on the exhaust energy being delivered to the turbo. All it's doing is holding the wastegate closed, if that's what you're talking about. Because the wastegate then just makes sure that all of the exhaust energy goes to the turbo. As long as you can hold the wastegate closed, that will happen. And then the spool rate is just going to be a function of how much motor we have and how much exhaust it has and how big the hot side of the turbo is. Why am I getting overrun with idiots here? And let's see, Celine 961. Runner length can make a big difference in where an engine makes power, but I've been told that longer runners won't add low RPM torque with positive displacement superchargers. Is this true? 100% not true. That's definitely false. Intake runner length always has the same effect whether you have boost on it or not. Let's see. Based on your experience, would you recommend E85 for long-term use? Yeah, we use it all the time and stuff, and I would use it, but there are considerations you have to make when you're using it for long term, I'm sure. When spammers show up, that's how you know that you've made it. So I'm officially successful then, right? I don't know why they would show up on a live feed like this. Lee, nitrous spools turbos faster on diesels, but I have no experience with it on gasoline engines. It does the same thing because it adds lots of power. And so more power, more exhaust energy, more turbo spool, all that works really well. Hey, Richard, what do you think about Holley turbo manifolds? I've used them and I have videos up on them. We've used them a lot. They're not designed. They're really designed to package very well, which they do very well. And they work good up to a given power level. They're not what I would use for like 1,000 horsepower stuff. If I was going to make a 600 or 700 horsepower deal and that fit in the package that I was trying to do, I think they work really well. Turbo Man, what's better for boost? There's no intake manifold that's better for boost. Holley High Ram or Super Victor 351 turbo, 20 pounds, 100 octane. I haven't done a back-to-back test of a Super Victor versus a High Ram. In fact, I don't think I've run Super Victors, but I have not run a Holley High Ram on the 351 or a 408 or 392 or any version of that. So I can't really say, but whatever they do NA, whichever one makes the most or the power curve that you want NA is then going to do that under boost. Charles, do you believe in de-stroking a big bore for turbo applications? I don't. The turbo has nothing to do with that. It's not going to change whether you want to de-stroke a motor. If you want to de-stroke a motor, that's normally to fit it in a specific class. If you de-stroke a motor and make the motor smaller, it's going to make less power. So if that's what you want, it's going to do that. What compression ratio should I shoot for on a small block Chevy Ironhead 383 on 91 octane and a 1-ton dually with a mild turbo build? I think it would be 10 to 1 or less. I think 9 probably would be better if you're going to run it on 91. Thanks for the clarification. My tuner is adamant that longer runners only added torque for NA, turbo, and centrifugal supercharged engines. I don't know how he would eliminate positive displacement supercharging out of that when all of the other things are also boost. What normally happens is you can't package long runners a lot of times with positive displacement blowers because they normally sit in the valley in the middle there. And you can't get really long runners a lot of times with that blower also, and then have it fit under any kind of reasonable hood. But that doesn't mean that it doesn't work. I mean, the guys from Engine Masters just did a test to verify this, and I've done it many times. They just ran a tunnel ram versus the stock low profile blower with, I think that they had an 871 on there or something. And they ran it with both of them. And the tunnel ram made more power than the short manifold did by a lot because it has longer runners in it. Josh, is it necessary to pin the crank when adding a Procharger on an LS3? Yes, you should definitely do that. And it's very easy. It takes like 15 or 20 minutes. Augustine, if I put a 469 comp cam and a Summit turbo, do I have to change anything on the motor? Yeah, you have to change a lot of things. You have to change the fuel pump and the injectors, the springs. All of that's going to be necessary. What kind of bearings for the crank and connecting rod do you recommend? I think the last time we were putting stuff together, we had Clevites or ACLs. There's all of those work. What's the lifespan on the 80 side inside a gas tank? Since it is the tank open, I mean, does it matter if it comes from a gas station or from a reputable company like Sunoco? The Sunoco E85 is going to be a race E85. Normally, they mix that with a better version of the gasoline that has higher octane. I know the stuff that we got from Rocket Brand was like that. I just go get E85 from the local gas station. I never even tested it. We just run it. Yeah, the percentage of the blend of E85 on the pump can vary dramatically for what we're doing. And I remember somebody telling me, and I haven't verified this, that the power difference between what they were measuring as an E50 and an E60 and an E70 and E80, that the power was essentially the same on all of those. I think below that, they started having issues and that it was different. So I figured if I'm in that sweet spot, and I'm never tuning to the last 5 horsepower, whatever we're trying to get out of a combination. And so for what we're doing, it's good enough, and it's a lot cheaper than trying to run race gas. Daniel, my question, Daniel, on the D-stroke stuff, a 3 1/4 inch stroke or and a 4 1/8 inch bore, all that's great. My question is, what would happen if you had a 4 1/8 inch bore and you had a 3 1/2 inch stroke, or a 4 inch stroke, or 3 750 stroke? Do you think that it would stop the RPM potential of the motor? The answer is no. In case you're wondering, it doesn't. Multi-movement man. Hey, I got the Chevy 229 Odd Fire V6. Okay, I'm familiar. Do you think with forged parts and boost? I think without forged parts, you could boost it and it would be okay. I think you just put ring gap in it, you could put boost on it, and it would surprise you if you had the tune right and you had the right size injector and you had an intercooler, and especially if you ran on E85 and you just ran boost on it, I think you'd be really happy. Salvador, can you speak on Whipple versus turbo advantages and disadvantages? At any given boost level, the turbo is going to make more power than a supercharger, whether it's a Whipple or a Kenny Bell or a TVS or any blower, because it doesn't have any drive loss. It doesn't have any parasitic loss associated with driving the supercharger. The superchargers have a lot more than that. And as you go up in boost and up in power, the losses go up dramatically. And especially if you're trying to push the blower out of its efficiency range, the drive losses go up like, way up. So that's not good. So a turbo will make more power, but that's not why people are picking it. Not because one is more efficient than the other. Guys are picking it because of the boost curve that it applies, the way that it looks, the way that it sounds, what the cost is, that some people don't like the heat associated with turbos. It's almost always a different thing. Hans, okay, Richard, I got a 2010 Camaro going with Power Glide and a stock bottom end LS3 ring gap twin 67s. Should I stay with a stock ECU at a boost controller or a standalone? As long as you can get the air fuel and timing that you want out of the stock one and add a boost controller, which is fairly easy to do, that works. If you need to do what a standalone can do for you, and there are other things that the stock ECU won't do, trans control or whatever it is you might want to do with the other standalone things, then that's something to consider. Richard, what's a safe power level for ungapped 5.3 on 91 Summit and on 3? I don't know. You don't know because you don't know what the gap is. Josh, aluminum or iron block LS, which one is better for a blower? They're both the same. They're both good. If you're talking about a 5.3, they're both the same. I wouldn't use unless you're for 1,000 horsepower, unless you can use whatever you want. If you're trying to get more than that, if you're going to do aluminum, only do a 5.3 aluminum block. Don't use a 5.7 or 6.0 or a 6.2. Just do a 5.3 one. Steve, I saw you guys running LS on Moonshine. Yeah, that was more of a gee whiz thing, but it was kind of fun. The Kenny Bell is actually not an auto rotor anymore. That's what they started with. Their 4x6 rotor pack is proprietary to them. A 500-inch LS would be nice. And that 495 that we did was pretty torquey. Music. Dan Hernandez from Denver, Colorado. What's the best cam you recommend for a 5.3 Carburetor LS street motor? It depends on what you're trying to do with it. The camshaft doesn't care that it's carbureted or fuel injected, contrary to what a lot of people will tell you. The carbureted induction system is just going to determine what happens with the motor. Like if you use a single plane, it's going to be soft down low and better up top, no matter what camshaft you put in. If you put a camshaft in it that's going to accentuate or aggravate that, and that will do that. So pick the camshaft for the power curve that you want to run, and whatever that is, you can do it with a carburetor. Dakota, howdy, Richard. Ever tested a Substack or Velocity Stack? Is it worth the money? We've tested them when we were doing Engine Master stuff, and especially when you run the old Substacks on the older style carburetors, they're less effective on the modern HP and XP stuff. But anytime you can have a radius entry like that, it can help. Sometimes when we had, especially on the older carburetors, We definitely had to go in and change jets when we used it, though. FA20 DIT Subaru WRX motor. I've never run any Subarus other on the chassis dyno, yes, but not on the engine dyno. Could you run 93 octane with 12.2 to 1 compression? Yes, you can, but you're going to have to be mindful of the tune and how much timing you put in it. Will a pack 1219 spring do well with 600 lift cam revving to 6800? I don't know. I don't ever remember using a pack 1219 spring set. Multi-move man. I've never run a Cadillac HT 4100. An 80-pound injector is going to be like 820 or 30 cc's or something like that. Just you use the rule of 10 to get an idea. Charles, we did the RHS tall deck block, and I did a 495 out of it, and we weren't at the maximum bore size, or I don't think we were at the maximum stroke size either. I think guys have done 510s or 520s, I think. Dakotas, we have tested E3 spark plugs. I wouldn't ever provide a generic number for stub stacks because sometimes they make nothing. So and on the right one, they might make more than that. So that's why we always test it. E3 spark plugs were not worth anything when we tested them. Barton, were you running a 3-port or a 4-port on the 4200? I have a 4-port, but I was thinking about trying to find a controller that can handle a dual 3-port to control each side of the wastegate separately. You can do that, and you can get creative. We ran a 3-port, and I've run that 3-port with that TC1 controlling 2 wastegates. So it's just, you're just splitting the lines, and it works really well. Richard, have you ever tested a set of L92 heads with an L676 intake manifold? If the L76 intake manifold is the same as the LY6, then the answer is yes. I don't know specifically about the L76 intake manifold because I don't ever remember getting one of those motors that I know that where that was stock. We've run the LY6 intake manifold a bunch, and I think that that's the same thing. Admiral's in the house. Dan, you want to see a budget 426 race Hemi build? Is that going to be sitting right next to the budget Porsche build? Would you allow any cylinder wall taper on a boosted setup with forged internals? You have 5,000s taper? And are you going to bore at 10 so that you can have it be straight? Brian, yours will be the last one I've got to get going. Thought of your Supercharger V6 testing. Grabbed a Supercharger off of 3800 before it got crushed the other day. Nice. So you saved one. That's good. Saved one from the crusher. So, Dan, I'm almost finished with my budget 3.3 liter turbo Porsche build. Yeah, that's going to be next to the Hemi one. Just got to finish welding those budget 321 stainless headers. Yeah, at least they're not, I guess Inconel would be big money also. So thank you guys all for showing up. And again, hope you guys all had a Merry Christmas. I missed everybody. I haven't been on for a couple of days because obviously we've been doing family stuff. But I'll be back on, and then after the first, heading down to Wastegate, so we'll be doing some fun stuff. More dyno testing, which is always awesome, and more motor stuff. And hopefully we'll get some T-shirts going here, and lots of cool changes coming. Thank you guys for showing up. I will see you all tomorrow.